well, we'll go ahead and get started then. My name is Travis Spencer. I'm the CEO of Curity. For those of you who don't know, Curity is a software company that provides a standard-based implementation of OAuth and OpenID Connect that runs on-premise or in any cloud. It does very, very advanced login stuff. It provides not only OAuth and OpenID Connect, but also a SCIM implementation so that you can do user management. And we are sponsoring this event, so if you want to find out more, you can come to our booth afterward. But for this 45 minutes, what I'm going to talk to you about is how to secure your APIs using those two protocols, OAuth and OpenID Connect, and how you can apply it in a microservices scenario. For myself, I am an identity management specialist. I've been working in this space since 2008 when I started in the financial services industry in the United States, and I've been working in that entirely since. I've worked for other software companies, I've worked for consulting firms, and now I work for Curity. Curity is also the organizers of Nordic APIs. Have you guys heard of this? It's one of the biggest API websites on the internet. We have a very, very active blog, putting out a couple of articles every single week on all aspects of APIs, whether it's security or business models or marketing or platforms or other aspects of APIs. We're talking about that. We have an extensive team of various bloggers giving their perspective, and if you guys would like to share your insights, you're always welcome to submit a blog proposal or to become a writer. And we also organize events, and we've had 30, 40 of them since the organization was founded in 2013. Our upcoming ones are in Austin, our second event in the United States, on June 11th to 13th. And then the biggest event that we do every year is the Platform Summit, which will be in Stockholm at the end of October. Both of those, I think tickets are for sale, and you can even submit a talk if you're interested in presenting. At least I know that the call for papers is still available for the Platform Summit. So today, though, I'm going to be talking about API security and how we can do that in microservices. And it's simple, so even though the room is getting very hot and uncomfortable already, it doesn't matter because we're going to be leaving here rather shortly. Because API security is really simply solved by API keys, right? So if we need to protect something, we have a key, and the key protects it, and so it's solved. And there's sort of this idea that if we just have API keys, then the problem is solved. But unfortunately, it's not that simple, because what is an API key anyway? It's a revocable, non-expiring bearer access token, if you're sort of geeky. If you're less geeky, it's a symmetric key. If you're even less geeky, it's just a password. I mean, it's just a long bunch of random bytes. And that can provide some identification if coupled with some sort of ID. It could even be used to provide authentication. But APIs, as they mature and get more and more complex and do different things, API keys is insufficient. So it will be just a little bit longer. We'll have a little bit more to say, but not much, because we'll just solve it, right? We'll just use OAuth and the problem is over. We'll protect our APIs with OAuth, but what does that even really mean? It's not that easy, unfortunately, to just throw OAuth at the problem and solve it, because as we'll talk about today, OAuth is really just a bunch of PDFs, and we need to turn that into running code. And the distance between those is quite substantial. So let's delve into what that is, keeping in mind the sort of context here. So we need to be, as we're securing our APIs and microservices, thinking about enterprise security, like keeping the computer safe, having intrusion detection, having physical security, to make sure that those APIs themselves are protected and the data that they're exposing. And then we have the API security itself, which is what we're going to be talking about, but also the endpoint security or the mobile security, making sure the devices have virus detection and various things like that. So I'm not going to be talking about these other two aspects, but we need to be thinking in a holistic manner, and just saying, okay, we're going to have OAuth and that's going to solve all of this is insufficient. But what's interesting is if we step back and look at those three sort of areas, enterprise security, mobile security, and API security, at the middle of that is digital identity. Who are you? I need to know who you are so that I can answer the more important question of what are you allowed to do. I actually don't even care who you are in most cases. I care what you're allowed to do. And so in order to do that, we need to figure out who's at the other end of our API, who's invoking our microservice. And digital identity is what we use to do that. And thankfully, these days, we have really, really good standards for this. We have better standards than we've ever had in history for securing data and APIs and figuring out who someone is in the digital space. So for authentication, we have a lot of different techniques. Some examples of NEO or new security standards for providing authentication are U to F. For provisioning, we have SCIM, which I mentioned in my intro. For identities, we have the JSON identity suite. For federation, we have OpenID Connect. For delegated access, we have OAuth 2, which we're going to talk a lot about today. And for authorization, we can use a standard called Alpha to actually do the policy rule definition. So I'm not going to talk about all of these today. The conference organizers were kind enough to give me a lot of time to talk today, but I would need the rest of the day or more to talk about all of these. So we're going to look at OAuth 2 and OpenID Connect in particular. Okay? So first of all, OAuth 2, you can think of it as sort of a protocol of protocols, or sort of a framework that we can use to build other protocols. So the idea and the intent behind OAuth 2 was to simplify the standard that was there before, which was OAuth 1, and to move the complexity from the applications and the APIs into the server, into the OAuth server, so that it's much, much easier to build applications, but consequently a lot harder to build servers. But this is fine because we'll have, 100,000 OpenID Connect servers or OAuth servers, but we'll have millions or billions of OAuth clients. And so by shifting the complexity to the server, we can begin to get economies of scale of those applications that are being developed to consume our APIs. Does that make sense? So because it's a framework, also other standards are being defined on top of it and sort of profiling it or specifying extra things where the OAuth standard allows for things like it may do this, or it can do this, or it's recommended to do this. These other protocols like HART and UMA and OpenID Connect say it must do this and it should do this. Other examples are FAPI, financial APIs being profiled and used a lot here in the UK and the open banking sector. And there's others, FHIR, many. So it's really a protocol of protocols. And the only other one I'm going to talk much about today is OpenID Connect. OAuth 2 implements or defines at the protocol level some really important things like delegated access, which we're going to talk about in a bit. It also reduces password sharing so that the OAuth client never ever, or the application never sees the user's credential, whether that's a username, password, or something else. And it also provides for a way to revoke the access. So like I cheekily said, cheekily, is that a British word? Cheekily? I don't know. Help me out. Like I said, the API keys are non-revocable. Or like once you have the API key, if you revoke that API key, you revoke all access. So with the tokens, it's only one particular token that is being revoked. So this provides us a more fine-grained way of doing revocation. OAuth actors. So it's important to know about the different entities that are involved in OAuth. The first, of course, being the OAuth server itself. So the thing that implements OAuth is called an authorization server or an AS. I always just say OAuth server, though, and I think colloquially that's what people say. We also have the resource owner. This is the user, typically. It's called the resource owner because the user might not actually own the resource. It could be something else that owns the resource. But 99% of the time, it's just the user. And then the client. The client is the one actually, the client of the OAuth server. And this is typically an application like a web application or a mobile application, something like that. And then we have the resource server. So the thing serving the resource, which would be the API or the microservice. Okay, so those are the four entities we need to be aware of. Because we have so much time also today, if you guys have short question that you can ask within like 2 sentences or something's not clear. We don't have to save it to the end when you've forgotten. So if something does come up, just ask and I'll repeat the question so that the video and other people can hear it. So are there questions? Okay. So to the end user, OAuth looks like this, where you come to some sort of application and it requests access, and that could just be like automatic. Like anytime you come to this application, you must be logged in, and you're not, and I can tell that, so ship you over to the OAuth server. It could also be like you're clicking a button, login or get started, or something like that actually takes you to a place where you need to be authenticated and allowed access. And so there will be some sort of process of requesting access that could be automatic or manual. Okay, and then somehow then at that point the user will have to get logged in. The OAuth specification doesn't say how you have to log in, just that you must. And so that could mean Morse code or carrier pigeon or know 2 people who know you, something like that. That's okay. You just need to log in. And login can be done through an entire process or workflow or getting signed up for an account. All that stuff can be happening as you're doing this login step. So keep that in mind when I just say login. I don't just mean like show username, password, and be done with it. You're really at this point only limited by your imagination. And then finally we have consent. So the user is allowing this application to do something on its behalf. And so there the user might be informed, do you want this application to do A, B, and C for you? And the user might say yes or no. But by and large, this screen is never seen. In almost all of our customer deployments, it's automatic because the application provider is the same as the OAuth provider. And in those cases, you've sort of agreed by terms and conditions or software license agreement or employee contract or something like that. So consent isn't required in the standard to actually be presented to the user. But there are other cases, especially when the OAuth server and the resource server, the API, are run by 2 different organizations. The one running the OAuth server is going to say, like, okay, if you let this application do this thing and they mess up your money or your medical records or whatever, it's on you. So there's very often in those sort of situations a consent screen so they can capture that and it becomes a legally binding agreement, or at least an audible event that can be referenced back to if things go wrong. Does that make sense? So this is the user experience. You've probably seen it. Some of you may even implemented. Anyone implemented this or working in, yeah? So you recognize this sort of process. And but let's drill into this. So OAuth defines a number of different flows. The standards, it talks about them as grant types. I still don't know what that means, but in any sense, it's a message exchange pattern or a flow. And one very common one is the code flow, it's called. So I'm going to show you behind the scenes what this end user experience looks like in a component diagram and an interaction diagram. So the application here will redirect to the OAuth server, and this happens in the browser. So this happens in like a system browser on a mobile device or the user's same browser that they're accessing this with. And then the user will be presented with some sort of login method. Again, here it doesn't necessarily have to be a username password. It could be like a bank ID or an SMS OTP or a smart card or whatever. And once the user has logged in, the OAuth server responds with something called an authorization code or an access code. And this is a one-time usage code. So it can only be used one time. And so it's called a nonce, or no more than once. And this nonce is provided on the query string of this redirect to this server in the code flow, mind you. And this code is redeemed here to the OAuth server and exchanged for an access token. And this is interesting because this part does not happen through the user's browser. So this is server to server here. And this call here is authenticated. And consequently, this token knows who this application was since it authenticated, and it knows who the user is as well, since the user authenticated. And it includes in this token information about the OAuth server itself, so that later on when we present this access token to the API, it knows all three of those things. It knows who the issuer of the token is, the OAuth server, who the user is that authenticated, and who the app is that user is interacting with. So the backend API now can make a very informed authorization decision about whether or not to allow access, because it doesn't just know the caller, but it knows the end user and also the security gateway or the security service that implemented or issued this token. And this is something we all wanted to do in the W star era, but was very hard. And this is baked into the protocol, and you can't even not do this when you're in the code flow. So that's sort of the revolution, so to say, of OAuth that is quite nice. Questions on the code flow? Clear? Good. So in the initial request here, you send various parameters. You don't have to send, but one of the things you can send is a scope. What you want to say is like the scope or the extent of the token abilities. So that's why it's called scope. It's like the application is saying, I want to have a token that will allow me to do all of these different things on behalf of the user. And it could be presented in some sort of consent screen, probably not one like this anymore. We did this back in, I don't know, like 2008-ish time frame, 2012-ish time frame. But we've learned better not to do this. But this at least illustrates the idea that you're asking for different rights. You're asking for a token that has more access than another one. And what's interesting about the scopes is that the user may or may not, depending on how things are configured and what the user does, not allow such access. So the user has a possibility to descope or narrow the access of that token or give away less of their rights to the application. And the way that they do that is through scopes. So another way to think about scopes is sort of their entitlements or permissions or like the group of claims, if that helps you, that the application wants about the user. And these scopes then are burnt into the token so that that backend API can see, did the user grant enough information or enough rights to this client, so I should allow this API call. Does that make sense? It's a pretty fundamental part of OAuth. It tends to be super confusing. If you have specific details of how to apply that to your situation, we can talk afterward. So another thing about OAuth 2 that you need to be aware of is that it includes two kinds of tokens. One is an access token and one is a refresh token. So an access token is sort of like a session, and the refresh token is sort of like a password. And I'll explain that in an analogy like a website. You come to a website and it makes lots of HTTP requests, and at the beginning it logs you in, and subsequently it doesn't have to keep asking you to log in because it has a session that it can keep using to make a better user experience. So that bootstrapping of that session is done with a credential that is sort of long-lived. It's your username and password. So that is like the refresh token. Whereas every single HTTP request with that short-lived token, like that session, is like the access token. Okay? So the refresh token is nice because then after that short-lived access token has expired, the client, the application, can get a new one by sending a refresh token to the OAuth server and saying, hello, could I please extend the session for the user? And as long as the user hasn't revoked the access, as long as the application can still log in, and as long as the refresh token is still valid, it will get a new access token and be able to provide a seamless experience then for the user. So of course, this is a more powerful token, so then there becomes other security implications of that, and you might only issue that to very trusted clients or clients that you know that can secure this powerful credential safely. And so, yeah, if you want to talk about specifics of how to apply that to your situation, Be happy to keep in mind that not all of these flows, like the code flow does, but not all of the other flows include a refresh token. We also have different profiles of tokens. We have bearer tokens and we have holder of key tokens. These are only now becoming more used in OAuth 2. Like 99% of deployments out there are bearer tokens. To help understand the difference, a bearer token comes from the word like bearer, like a bearer bond. So the one who bears the token is the one that gets the access. So if I'm lucky enough to find £5 out in the street, that's a bearer note. So the one who bears the note is the one who can spend it. I can go into Starbucks and I can buy myself a coffee. And the barista is not going to ask me, like, where did you get this £5 note? Did you find this on the street? It's like the barista will just accept it as is. Whereas a holder of key is more like a credit card. So the token is bound to the one to whom the token was issued. So a credit card, my credit card was issued to me. It has my name on it. I have a PIN. And so if you find it on the street, you're not going to be able to take it and buy yourself coffee because you're not going to know the PIN, first of all. But even if it was a magnetic one, the barista would ask you for a signature, some sort of proof that the token or the credential or the credit card was issued to you. And so it's bound to you. And so, of course, different security implications and different results of using those two different profiles of tokens. Okay. There's also types of tokens. One of the original criticisms of OAuth 2 as it was being drafted was that it didn't define the token type like was done in WS security, where the username token, the SAML token, all of these things were profiled, and that's what they are. In OAuth, it just said it's a thing, and this has actually turned out not to be a problem, but a real a benefit or a good thing about OAuth, because it helps with interoperability. It helps you to interop with legacy systems, and it helps you to create different security postures and different security measures, which we're going to talk a lot about when we start talking about microservices. So you can have WS security and SAML tokens. You can have custom homegrown tokens, which actually is, I would even say, the most popular. You can use old access manager tokens. You can use CBOR web tokens, which are like binary tokens. And then you can use JSON web tokens. So probably all heard of JSON web tokens, pronounced like the English word jot, like to jot something down quickly or write it quickly. They're meant to be very lightweight tokens that are passed in HTTP headers and HTTP query strings. Although, of course, passing them in query strings is discouraged, but it can be done. They're meant to be very small and compact so that it can fit in HTTP streams very easily. They're encoded as JSON, which is nice because it results in a very low technology barrier. It's easier to find JSON encoders in programming languages than XML encoders. It also doesn't bring with it the security concerns that you would get in using an XML format, where you can have character escaping and DTD inclusions and different normalization and canonicalization attacks that just can't exist in JSON that do exist in XML. So by using that, we already have a higher security and lower adoption. So it's a really nice format. It's compact. You can sign them, you can encrypt them, or you can skip all of that if you're protecting the data some other way, like over mutual TLS. The signature over the token doesn't make any sense. And so the signing of it is also optional. But keep in mind, like I said, it's not the only kind of token that we can use. I think a lot of people, they hone in on JOT, and JOT is like somehow solving everything. It's maybe the next time I give this talk, I'll say like JOTs, and then we're done, right? We've got API security. But it's just a way of packing JSON together and putting the signature, the encryption around it. So it's a piece of the puzzle, but it's certainly not the puzzle. So we also want to talk about ways of passing tokens. So tokens can be passed either by value or by reference. So this is sort of a programming metaphor, if you will, me and my metaphors. So you can pass tokens by value. This means that all of the attributes are in the token. So the actual token format, whether that's JOT or SAML or CBOR or your own thing, has first name, last name, account number, maximum transaction fee per day, whatever. It has those sorts of things burnt into the token. That's a by value token. A by reference token, or you might call it a handle token, that actually refers to the identity information. So this is a pointer to it, and usually this manifests itself as just like a GUID or a few random characters that can be dereferenced to point to the actual identity data. And the analogy related to programming, right? So you call something by reference, you have the data on the heap and you pass the pointer and you dereference that to find the data. If you pass it by value, push it all on the stack. So you see what I'm talking about here, right? Questions? Good. So let's talk about some improper uses of OAuth. So OAuth is not for authentication, right? I said before, the OAuth standard doesn't say even how to authenticate. It just says like you must authenticate. So the auth in authentication is not for authentication. It's also not for federation. What is federation even? Federation is figuring out who somebody is in one security domain or realm and reusing the answer to that question in another domain or another realm without having to ask them again. So it's certainly not that. And here I'll make a bold statement. It's not for authorization. So the auth and authorization, or in OAuth, isn't for authentication or authorization. That seems weird. It's true though. What is it for? It's for delegation. Okay? Maybe I'm splitting hairs here, but to explain what I mean and to help you guys understand how to apply this correctly, think of an analogy like this. I'm a business owner and I hire an assistant to help with keeping the books of the company. And I say to the assistant, you can take money out of the company account. And so then the company, this new assistant goes down to the bank and says, I'd like to take out £10,000 from the bank account. And the banker then is going to say, I'm sorry, but you can't do that. You're not authorized. And the new assistant might say, but the owner of the company gave me this right. Sure, the owner of the company delegated you that right, but you're not authorized because neither you nor the business owner came down and signed the right papers or did the right things, and so you're not authorized. So all the business owner did was delegate the business owner's rights to the assistant. So the same is true here with OAuth. The application is receiving rights that are being delegated to it by the user or the resource owner, but still the authorization decision lies at the API. And the closer and closer we get to that resource that is exposed to that API, the more fine-grained that authorization check is going to get. So if it's going to be passing through these different hoops, there might be different layers of authorization. So finally, when it gets right next to the resource, that one is the one that's going to make the final decision of whether or not it should return that data. And OAuth doesn't help there. It just gives an input into that decision of whether or not you should have that access. Does that nuance make sense? We can argue about whether or not it's correct later, but I believe it is. So OpenID Connect, as I said, builds on top of OAuth. It's really a next generation federation protocol. This is allowing you to take the answer to that question of who are you and use it in other domains. Sometimes those might be your own applications, but it could also be others. It's based on OAuth 2. It's made with mobile in mind. So it's using JOT tokens in some cases because they're profiled for small environments. It's not backward compatible with OpenID Connect 2, if you've ever heard of that. And it provides the sort of novelty of this is that it adds new flows. So a hybrid flow, they call it. It provides an ID token because the application didn't get invited to the party and didn't get any information about the user in the access token. And it also provides an API, a standard API for getting additional user information. So here's the code flow again. But this time we ask for OpenID scope. And this sort of clicks the OAuth server into OpenID Connect mode, because most of the time the OAuth server will be both. And it provides that access code like before. The access code is redeemed for an access token. And this time we get not only a token for the API, but the app is invited to the party and now has an ID token of its own. So that ID token is for the app. The access token is for the backend API. So that ID token could have information in there like, star dash last four of your account number, because the front end only needs that masked information about the account number. It might have maybe the first name to greet the user, but it doesn't have more than that. So the access token for the backend might have, the full account. It might have the full name. It might have additional stuff in there. So by splitting those tokens up, we can provide the right amount of information to the right entity. And then if it needs to get more, it can provide or can call that user info endpoint and get that allowed information about the user. So the access token is for APIs, whether that's the user info endpoint or other APIs. The ID token is for the client. That's the big thing here. So the ID token includes information about the user, how they logged in, stuff like this. But the ID token should not be passed around to APIs. That's really an anti-pattern. What time do we have here? 16 minutes. So user info. So this is really about calling and getting additional user information. The important part here is that when you call and say, like, could I get more user information, it's secured with an access token. And that access token has scopes in it, and so the OpenID Connect user info endpoint will not release more information than that token is scoped for. So if you ask for first name, last name, email, all of this business, and the user said no, calling the user info endpoint isn't going to get you that data. Okay, so it's sort of the scoping is used in that sense and standardized in how that should be used. Right, that's what I'm saying here. It depends on the authorized request. Questions? Okay, so now let's switch gears. If you need to stand up and stretch a little, we're almost done though. But let's apply this to microservices and how we can use this in microservices. So traditionally, a service is, it's a whole thing, and all of the different components are in it, right? And that was fine. Except when we wanted to scale it, we had to make a copy of it and scale all parts of it. And maybe, some parts of it didn't need that scalability, and so it was sort of wasteful. And in some sense, it's harder to develop because the whole thing is there. So it's not always the way that we want to build systems, especially these days. We want to sort of decompose those monolithic applications into smaller ones and more discrete applications or microservices. And we end up with many of these different microservices. And as a consequence, we can scale these more easily where this pink example might need additional scaling, whereas the yellow might need less of it. So we can deploy it in a more fine-grained manner. But how do you secure these? This is really the kicker. This is the way we did it traditionally, was we put some sort of middleware, whether that was an in-process component or another server or an app container or something that would check to see that you're allowed to have access. And it would maybe contact a user repository and do all of that. And then finally, once it did, it got out into these ones. So this here is also like the web application management paradigm. Put something in the middle. So how does this work for the microservices? It sort of undoes all of the point of microservices, right? So if we have that proxy thing in the middle that's doing all of this checking, the shared database is an anti-pattern in the microservices architectural paradigm. So this is not going to work, or if we do it, it's not going to be great, or we're going to miss some of the benefits of microservices. So let me give you an alternative. Remember that there are different ways of passing tokens. So we can pass tokens by value, or we can pass them by reference. So what we want to do is we want to make sure that the by reference contains no information that should be shared outside of the network. any information that is not for the microservices should not be in that token. The by value token should include all necessary information, identity information that the microservice needs. That doesn't mean like, absolutely everything under the sun that the microservice is going to operate on, but at least the identity information so that we don't have to make this sort of call, right? So we want to go from just a pointer that contains no information that should not be shared outside the network to one that contains all identity information that the microservice needs. So we need to have some sort of way of going from the reference on the outside to a by value on the inside. And usually with these microservices that are HTTP based, there will be some sort of proxy in the middle doing some sort of caching or throttling or security. And so this puts it in an ideal situation to make that translation from a by reference to a by value token. So the way that happens is the by reference token from the outside the network, so coming in from your mobile app or even your web app, is coming into the reverse proxy of the API firewall, and we're sending that ref token to the OAuth server, dereferencing that into a by value token, and sending that by value token back to the APIs in the backend. As a result, now this by value token contains, like your full account, your full name, things like this, and a digital signature over that. And these backend microservices can verify that by just checking the digital signature over that information. So all they have to do is have a copy of this one's public key. And the way that they can get that is on boot up, there's a standard actually as a part of OpenID Connect called JSON web keys, where they can go and fetch the modulo and the exponent, pull that down, and create the public key. And then if a token comes in, it will have a reference to that key ID, and they'll be able to verify it. And if they don't have it yet, they just make another fetch and get the JWKS, recompute the public key, and verify the JOT token. So it's super simple to do. You don't need like big PKIs and all this mumbo jumbo. You can have that mumbo jumbo if you want to, and it still works as well. But it makes for a super lightweight way of verifying tokens in those microservices, so they don't have to access any shared user database or any database at all for user management. They're just given the basic identity information that they need, keeping them super simple. And also, as a consequence, this API gateway or reverse proxy even can cache this. So this has a time to live, a sort of expiration. So this gateway can be told, and these gateways have simple ways of just doing HTTP caching by configuration almost always. So if the OAuth server responds with HTTP caching information, it could say like, okay, when you see that ref token, you can cache the result to that by value token for, 300 seconds or however long that token is supposed to last. So that with every further API call, there is no sideways call to the OAuth server. And furthermore, because these ref tokens are usually GUIDs or globally unique identifiers, that cache can be global. So all of your microservices, whether you have 1 or 1,000 back here, can share that same cache. So even if you're calling the same backend APIs with the same front-end ref token, you'll always hit the same cache and not need to do that across all your different 1,000 microservices. Does that make sense? Okay.
Sure.
Yep, please. Say again?
What's the benefit of using the reference on the client side?
Great question. So, like, even if you say this is poppycock and I'm not going to do this or whatever, that's fine. But keep using the ref token, because then it makes sure that the client, the mobile app or the web app or whatever, it doesn't accidentally take a dependency on the identity information in the access token. Because remember, the access token is only intended for the API, and if you're using a JOT for that, it has all of this juicy identity data in there that the web app might be starting to pluck out of there, maybe even without checking a signature or anything. And then all of a sudden, your API says, I need to have something else instead. Your OAuth server changes what's in the token, and your front end breaks. So the ref token helps to make sure that the clients don't take a dependency on data in a token that's not for them. It should be in the ID token instead.
So it's more an issue of decoupling it more than a security concern.
so in that respect, but it's also a security concern because the ID token that is for the front end might not have the full account number or the full patient record number. It could have something that's masked, right? Because it's really just for display, so to say. So if in those sort of cases, they become unregulated. So it's these that are in the regulated space. And then, so that's regulation. But on the security aspect of it is like, the alternative to this ref token is an encrypted token. So then the front end can't peer into it. Yes, we have encrypted data out here in the wild, but it's encrypted with blah, blah, blah. So we're safe, right? But the thing about encrypted tokens is you're putting the decryption input into the hands of the attacker and saying, I dare you. I dare you to decrypt this. And if you get it wrong, then they win. And so rather than giving them this sort of challenge, just give them a long string of bytes that they can bang on as long as they want to and will never get anything from. So it helps with security, helps with regulation, and it helps with the separation of the front end and the back ends. Great question, yeah?
Is there a way to enforce the client to always use only by reference?
It's configured in the OAuth server.
Oh, you can do it.
So the OAuth server is going to look at, okay, here is client A. This is a front-end application. It should get a ref token. Whereas maybe you have microservice talking to microservice. It's like don't make them do this hoopla. They just want to call the other microservice directly. So give them a by value JOT token so that they can quickly provide additional data to that other microservice. So it's usually per client that you would depict that. Great questions. Others? I'm getting to the end of my talk anyway, so if you have questions. Yeah? Yeah?
The issue with reference tokens that we've come across is that there's no way of finding out who was the issue.
Right.
So if you have an access token and let's say you're supporting multiple authorization servers in your gateway, then if you get a by value token, you know who was the issue, and you can see if that's an issue that you trust.
Mm-hmm.
You can go there and verify the token.
Sure. So there's two alternatives. Your ref includes the issuer, right? Because it's just whatever. So it could include like go here to dereference it. But then if you want to do it in a more structured and standardized way, you might make a JOT token that includes the issuer and only some sort of random ID, like a JOT ID. And so that as it's coming in, you have the issuer of that, and you can say, okay, it's over here. It's this one's endpoint that I should use to introspect that and look inside that token. And the HEART standard that I mentioned, which is a profile of OpenID Connect for healthcare, a HEART token is a ref token with the issuer wrapped around it. So just a little bit of metadata, I think, will help you to do that. And you'll need to do that if you're doing multi-tenant deployments. More questions? Okay. So here's some references for you. Maybe take a quick picture of that. Most of these are to the Nordic APIs blog, where we have quite a repertoire now of different security-related information, including a pretty good deep dive and some different aspects of security and etc. And then some videos if you want to refer back to that before this one gets out, and then some white papers. And this website here in general has a bunch of Nordic API security-related stuff there. And so in summary, API security is greater than API keys. We're going to have to do a lot more than just have API keys, which are providing very minimal and very simplistic security. OAuth 2 fundamentals, we have different token types, we have different profiles, and we have different ways of passing tokens. OpenID Connect builds on top of OAuth, and we can use those different passing methods, those different token types, and those different standards with our microservices to provide user-based delegation. So thank you for joining, and in the 3 minutes that are remaining, I'm happy to take your questions. We're here all week. We have a booth out in the Expo Center, so you can also grab me there. So thanks.